Okay, this is the trig unit review. Okay, so, a 20-foot ladder is leaning against a wall. The base of the ladder is 3 feet away from the wall. What angle does the ladder make with the ground? So on these word problems, the first thing we want to do is read it through once. The second time we read it, we want to draw the diagram as we go along. So here we have a 20-foot ladder is leaning against the wall. So we're going to have a wall. Okay, so there's our wall. We have a 20-foot ladder leaning against it. So here's our ladder, 20 feet. We want that to be green. Okay. So we have a wall and we have a 20-foot ladder leaning against it. Right? You got to imagine this in real life. When you're actually in real life leaning a ladder against a wall, that's going to be the hypotenuse. It's going to be at a diagonal. It's not going to be straight up or down or straight on the ground. So we have a 20-foot ladder leaning against the wall. The base of the ladder is the bottom of the ladder. The base is the bottom, is 3 feet away from the wall. What angle does the ladder make with the ground? So we put the 3 on the outside. So here's the ground. Okay, here's the ladder. Right. So we want the angle the ladder makes with the ground. That's going to be this one. We'll call it x. Okay. So we have to find that angle. So if we're solving for an angle, we want to use one of the inverse trig functions. So we have our triangle. It's a right triangle. We want to label our parts. 20 is going to be the hypotenuse. It's across from the right angle. 3 is next to the angle we're looking at, the angle between the ladder and the ground. So that's going to be adjacent. It's next to, so it's adjacent. So we have information on the adjacent and the hypotenuse. So that's going to be cosine. So again, it's inverse cosine because we are solving for the angle. We're inputting the ratio and the output is the angle. So inverse cosine, our ratio is 3 over 20. And that's going to be equal to our angle, which we call x. So the inverse cosine of 3 over 20 inverse cosine 3 divided by 20 is going to be 81.4. 81.4. Okay, degrees, 81.4 degrees. Okay. So it's inverse because we're solving for an angle. Okay, number 2, the bottom of the ladder must be placed 3 feet away from the wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? So second time through, we want to draw as we go. The bottom of the ladder must be placed 3 feet from a wall. So here's a wall. The bottom of the ladder is 3 feet away. Okay, and we're leaning the ladder against the wall. So here's our wall. Okay, here's the ladder. Leaning it against the wall. It's 3 feet away. The bottom is 3 feet away. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? So that's going to be x. That's what we're trying to find. Okay. So here's our right triangle. We have 2 sides of the right triangle. We want to find the third side. So if we have 2 sides and we want to find the third side, we want to use the Pythagorean Theorem. So this is going to be a squared plus b squared equals c squared. A and b are the legs of the triangle. Okay. So the legs are the ones that are next to the right angle. So x is a leg and 3 is a leg, and 12 is the hypotenuse. Okay, so we're going to have x squared plus 3 squared equals the hypotenuse squared, which is 12 squared. Don't just put the 2 numbers because I know a lot of you guys are just going to do 3 squared plus 12 squared equals x squared, right? We can't do that. It's the leg squared plus the other leg squared equals the hypotenuse squared. Okay, the hypotenuse is the longest side, so it's got to be by itself. Okay, x squared plus 9 equals 144. Subtract 9 from both sides, we get x squared equals 135. We take the square root of both sides to get rid of the square. We get x equals, that's not a perfect square or anything, so it's just going to be square root of 135. Okay, or you can put the decimal if you want. All right, number 3, the diagonal of a rectangle. So we have a rectangle. Well, read it through once. So the diagonal of a rectangle is 25 inches. The width is 15 inches. What is the area of the rectangle? Okay, so we have a rectangle with a diagonal. The diagonal is 25 inches long. Okay, we know rectangles all have right angles, so we have a right triangle. Okay, the width is 15 inches. What is the area? So area is 1/2 base times height. Okay, so we need the base and the height. Here's the base. To find the height, we need to find x. Okay, so to find x, we have two sides of a right triangle. To find the third side, again, we want to use the Pythagorean theorem, just like in number 2. So a squared plus b squared equals c squared. So the legs are a and b, so the legs are the ones that are next to the right angle. So that's x and 15, so x squared plus 15 squared. C is the hypotenuse. So 25 is across from the right angle, so 25 is our hypotenuse, 25 squared. Okay, x squared, this is 225. 25 squared is 625. Okay, subtract 225. We get x squared equals 400. To get rid of the square, we got to take the square root of both sides. And we get x equals 20. Square root of 400 is 20. Plus or minus 20, but we can't have a negative length, so it needs to be positive 20. So now our triangle has a base of 15 and a height of 20. And a height of 20. So that's going to give us 150. So our area is going to be 150. Number 4. So a ladder is leaning against a wall. The foot of the ladder is 6.5 feet from the wall. The ladder makes an angle of 74 degrees with the level ground. How high on the wall does the ladder reach? So again, a wall is a wall. Okay, we have a ladder leaning against the wall. The ladder is, okay, the foot of the ladder, the foot, meaning the base, the bottom, right? Your feet are on the ground. So the part of the ladder that's on the ground is 6.5 feet away from the wall. Okay. The ladder makes an angle of 74 with the ground. So here's the ground. Here is the ladder. So it makes an angle of 74 degrees. How high on the wall does the ladder touch? So that's going to be how far up the wall does the ladder touch. So there's our right triangle. We have one angle and one side, so we want to use, and we're trying to find a side, so we want to use the trig functions. So let's label what we have. Hypotenuse is the ladder, that's the diagonal. Okay, across from 74 is the opposite side. Next to 74 is the adjacent side. So the ones we have information on are the opposite and the adjacent. That means we're going to use tangent. So tangent of 74 is going to equal x over 6.5. Opposite over adjacent. So we have to solve for x now. So we need to multiply both sides by 6.5. 6.5. So we get 6.5 times the tangent of 74 equals x. So it's going to be 6.5 tangent of 74. It's going to be 22.7. So the ladder touches the wall 22.7 feet above the ground. At a point on the ground 50 feet from the front of a tree, the angle of elevation to the top of the tree is 48 degrees. Find the height of the tree. So a point on the ground is 50. So we have a tree. Okay, there's a tree. There's a point on the ground 50 feet away where the angle of elevation, elevation, that's the angle going up, okay, is 48 degrees. Find the height of the tree. That's then going to be the height is the vertical. So there's our right triangle. The height is x. Find the height of the tree. So again, we want to label this as opposite. It's across from 48. And this 50 is next to, so it's adjacent. So if opposite and adjacent, that's going to be tangent. So tangent of 48, it's just like the last one, equals x over 50. Multiply both sides by 50. So 50 tangent 48 is going to equal x. So 50 times the tangent of 48, that's 55.5. Number 6, we have a kite is flying 115 feet above the ground. The length of the string to the kite is 150 feet, measured from the ground. Find the angle of elevation of the string. Okay, so we have a person flying a kite. Okay. Again, you have to imagine yourself flying a kite. Okay. So this flying a kite. Okay, so the string of the kite is 150 feet long. That's the diagonal. That's your hypotenuse. Okay, the length of the string. Okay, the kite is flying 115 feet above the ground. Okay, so the angle of elevation. Okay, so we can ignore the guy. So, right, we're flying a kite. 150 is the length of the string. 115 feet above the ground. Find the angle of elevation. So the angle going up. So here's our right triangle. For finding an angle, we're using an inverse trig function. Okay, so we want to label our sides. Across from the right angle is the hypotenuse. And is the 115 next to or across from? It's across from the angle in question. So that's going to be opposite. So we have opposite and hypotenuse, so it's going to be sine. So sine of theta is going to equal 115 over 150. I'm sorry, we're doing inverse. We're solving for an angle, so we're doing inverse. My mind's on something else right now. So we're solving for an angle, so it's inverse. So it's going to be opposite over hypotenuse, so 115 over 150 is going to equal our angle theta. Okay, so inverse sine 115 divided by 150. 50.1. We're going to have to switch to iLearn from iBlog. That's what I was thinking about. Because apparently we're in a bit of copyright infringement with some of the stuff I put on the blog. So we're going to have to switch to iLearn. All right, sorry. Again, I was thinking about it. Okay, so our angle of elevation is 50.1. 7 through 14, we want to find x, or the missing angle. Okay, number 7, we have a missing angle. Let's call the missing angle x. Okay, what we want to do on these, label what we have. So our hypotenuse is across from the right angle. Okay, so it's 13 and 16 are the two legs. We want to find which one is across from. It's 13, that's opposite then. Next to is 16, so that's adjacent. We're solving for an angle, so we're using the inverse trig functions. So opposite and adjacent is tangent. We're solving for an angle, so we want to use inverse tangent. And tangent is opposite over adjacent, so that's 13 over 16, and that's going to give us x. So inverse tangent of 13 over 16 gives us 39.1 degrees. 39.1 degrees is x. Our angle here is 39.5 degrees. Okay, number 8, we have one angle and one side, and we're trying to find a second side, so we're going to use trig functions. So let's label what we have. So hypotenuse is across from the right angle. Across from 40 is the opposite side, the opposite leg. The leg next to 40 degrees is the adjacent leg. So opposite and adjacent is tangent. So the tangent of 40 is going to equal opposite is 20, adjacent is x. Okay, we're solving for x, so we got to get x by itself, which means we can't have it in the denominator. So we got to multiply both sides by x to get it out of the denominator. So we have x tangent of 40 equals 20. Then again, we want to get x by itself, so we got to divide by the tangent of 40. So these cancel, and we get x equals 20 divided by the tangent of 40. We put that in the calculator, 20 divided by tangent of 40, 23.8. So the length of the adjacent side is 23.8. All right, number 9, we have two sides. We want to find the third side, so that's Pythagorean Theorem. A squared plus b squared equals c squared. Okay, A and B are the two legs. So the two legs are x and 3.6. C is the hypotenuse. The hypotenuse is across from the right angle. That's 7.4. So A and B are next to the right angle. So x squared plus 3.6 squared equals 7.4 squared. So we get 3.6 squared is 12.96. 7.4 squared is 54.76. Okay, we subtract 12.96 from both sides. X squared equals, so subtract that's 41.8. We want to get x, not x squared. So to get rid of the square, we have to take the square root of both sides because that's the inverse operation. So we get 6.5. X equals 6.5. Okay. Oops. X equals 6.5. Okay, number 10, we're solving for an angle. Okay, if we're solving for an angle, we're using one of the inverse functions. So across from the right angle is the hypotenuse. Okay, across from the angle in question is the opposite side, and next to the angle in question, the leg next to the angle in question is the adjacent leg, the adjacent side. So we have information on opposite and adjacent. That's tangent. We're solving for an angle, so we want to use inverse. So inverse tangent. 10 over 33. So inverse tangent of 10 divided by 33 is 16.9. You call it x. So x, the angle x equals 16.9 degrees. Oops. 11, 12, 13, and 14. So 11, we have one side, one angle, and we're trying to find another side, so we're going to use a trig function. So let's label it. Across from the right angle is the hypotenuse. Here's the angle in question. Across is opposite. Next to is adjacent. So we have adjacent and hypotenuse, so we're going to use cosine. So we're solving for a side, so it's just regular cosine. So cosine of 54 is going to equal adjacent over hypotenuse, so that's 10 over x. Okay, we got to solve for x, so we got to get x by itself. So multiply both sides by x. Okay, we get x cosine 54 equals 10. Divide both sides by the cosine of 54. And we get x equals 10 divided by the cosine of 54. So x is going to equal 10 divided by cosine 54, 17.0. Number 12. Okay, we have two sides of a right triangle. We want to find the third side of a right triangle, so that's Pythagorean theorem. So a squared plus b squared equals c squared. So the legs are a and b, so the legs here are 4 and 8, and the hypotenuse is x. So we're going to have 4 squared plus 8 squared equals the hypotenuse squared. The hypotenuse is x. So 4 squared is 16, 8 squared is 64. That's going to give us 80. So we want to get x by itself, so we're trying to solve for x, so we got to take the square root of both sides, the inverse of the square. So x equals the square root of 80. We can get a decimal, we can leave it like that, we can simplify it. So what do we have? 4 times, so 16 times 5. Right? So that's going to be 4 root 5 equals x. Okay, number 13 here. So here's the angle in question. 17 is the hypotenuse. X is across from 59, so that's opposite. So opposite hypotenuse is sine, so we're going to do sine of 59 equals opposite over hypotenuse. Okay, multiply both sides by 17. So 17 times the sine of 59 is going to equal x. 59. So we have 17 times the sine of 59 is 14.6. Oops. 14.6 equals x. Then here. Okay, we want to find an angle, so we're going to use an inverse trig function. So here's the angle, let's call it x. 23 is the hypotenuse, it's across from the right angle. 20 is next to x, so that's adjacent. If we have adjacent and hypotenuse, we want to use cosine. If we're finding an angle, it's inverse cosine. So inverse cosine, the ratio is adjacent over hypotenuse, so 20 over 23. Okay, and that's going to equal our angle, which we are calling x, or question mark. So the inverse cosine of 20 divided by 23 gives us 29.6. The angle is 29.6 degrees. 29.6 degrees. It's 14. All right, let's go to 15 and 16. These ones, we want to use the properties of special right triangles. So 15 is a 45, 45, 90 triangle. Right, it's a 45, 45, 90. Okay, so for the two equations for this one, we know that the hypotenuse equals the leg times the square root of 2, and we know that the leg equals the hypotenuse divided by the square root of 2. Here we have the hypotenuse. We want to find the two legs. It's 45, 45, 90, so we know the legs are going to be equal. If we have the hypotenuse and we're trying to find the leg, we're going to use the second equation. So the hypotenuse is 10. We divide by the square root of 2. Okay, but we don't want that radical in the denominator, so we have to rationalize the denominator. So we want to multiply by square root of 2 over square root of 2, which is 1, right? You can multiply in math by 1. Square root of 2 over square root of 2 equals 1. Just another way to write 1. So that's going to give us 10 root 2, square root of 2 over square root of 2 times square root of 2 is the square root of 4. We know the square root of 4 is 2. And then 10 divided by 2 is 5, so we have 5 square root 2. So both legs are 5 root 2. Okay. This one we have 60 degrees and 90. We know the three angles of a triangle have to add up to 180. So 160 plus 90 is 150. 180 minus 150 is 30. So we know we have a 30, 60, 90 triangle. So in this one, we have to know which one's the long leg and the short leg. Well, 20 is the hypotenuse because it's across from the right angle. Okay, we know F is the short leg because it's across from the shortest angle, which is 30, the smallest angle, which is 30. Okay, and then G is across from 60, so that leg is the long leg. Okay, and again, our two equations we have for 30, 60, 90 are hypotenuse equals 2 times the short leg. And we have the long leg equals the short leg times the square root of 3. So we want to find F. F is the short leg. So we can put it into the second equation. So the hypotenuse is 20. It's 2. And the short leg is F. So to solve for F, we simply divide by 2. So 10 equals F. Right? The short leg is half of the hypotenuse. The hypotenuse is twice the short leg. Okay, we want to find the long leg. We can just put it in the long leg equation. So the long leg equals the short leg times the square root of 3. So the long leg is G. Short leg is F, which we found out to be 10. And then we have times the square root of 3. So 10 square root of 3. Short leg's half the hypotenuse, and the long leg is the short leg times the square root of 3. Okay, 17. Okay, wants us to find the ratio, so we want to put the fractions here. Okay, so D, so here's angle D right here. Let's label our sides. 5 is the hypotenuse. 3 is across from, so it's opposite. 4 is next to, so it's adjacent. Sine is opposite over hypotenuse, so opposite is 3, hypotenuse is 5, so 3 over 5. Cosine is adjacent over hypotenuse, adjacent is 4, hypotenuse is 5, so we have 4 over 5. Tangent is opposite over adjacent, opposite is 3, adjacent is 4, so we have 3 over 4. Okay, the second column wants angle G. So we have, the first one we were looking at angle D. Okay, so opposite was 3, adjacent was 4. Okay, but if we switch to angle G, okay, the hypotenuse stays the same. It's 5. If we're looking at angle G, which one's next to G? That's 3. So 3 becomes the adjacent, and 4 is across from angle G, so that becomes the opposite. So sine is opposite over hypotenuse, so opposite is 4, hypotenuse is 5, 4 over 5. Cosine is adjacent over hypotenuse, so that's 3 over 5. Okay, and then tangent is opposite over adjacent, so that's 4 over 3. Okay. Just got to write the ratios. So good job. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, number 18, we want to find y and z. Okay. So what we really want to do here is we want to look first at the large triangle. There's 2 triangles here. Okay, right, there's the large triangle, the red one, and then there's the smaller one with the 54. Okay, so right now we're not even looking at this. Okay. We're not even looking at that part in the middle. We're looking at the big triangle. To find y and z, so to find y, we're going to have to know the height, and then to find z, we're going to have to know the base. So we need to find the height and the base of this large right triangle. So I'm going to call the height w, and I'm going to call the base x. So if we need to redraw it, I'm going to redraw it over here. Here's our big triangle. Okay, this is W, this is X, this is 35, this is 23. So that is this triangle right here, the big one. Okay, W is the height. You can make it any variable you want. I'm just using W. A, B, S, and T, whatever you want. W, and I made the base X. Because we need to find the base and the height. So let's label it. Here's 23. Okay. Well, across from the right angle is the hypotenuse, right? So across from your right angle is the hypotenuse. Across from the angle in question is the opposite side. So W is across, so it's opposite. X is next to, so it's adjacent. If you want to look at this one, right? Across, so that's opposite. X is next to, so it's adjacent. So if we want to find W, we want to use the hypotenuse. So W is opposite, 35 is the hypotenuse. So opposite and hypotenuse, that's sine. So we want to do sine of 23 equals W over 35. Okay, to find W, we want to multiply both sides by 35. So we get 35 times the sine of 23 equals W. That those canceled. All right, so 35 times the sine of 23, 13.7. So 13.7. Okay, now we want to find the base. So the base is adjacent. So we have adjacent and hypotenuse, right? Adjacent and hypotenuse. So we want to do the cosine of 23 equals the adjacent over the hypotenuse. So that's going to be X over 35. You want to multiply both sides by 35 because we want to get X by itself. So we have 35 times the cosine of 23, the cosine. Okay, equals X. Okay, so 35 times the cosine of 23 is going to give us 32.2. That equals X. So I'm going to erase this one now. We found X was 32.2 and W was 13.7. Okay, so we found the base and the height now. Okay, now what we want to do is we want to look at, so we can replace these in here. We found W to be 13.7 and we found X to be 32.2. Okay. All right, so now what we want to do is we want to look at the inside triangle here. So let's look at now this triangle. Okay, the angle in question is 54. We notice the base of this triangle is y, so we can find y, right? We have the height, which is 13.7, so we can find y. So we want to use, so we want to label it, right? So we have 13.7 is opposite, y is adjacent. So we have opposite, we want to find adjacent. Opposite and adjacent is tangent, so we're going to use tangent of 54. Okay, is going to equal the opposite, which is 13.7, over the adjacent, which is y. We want to solve for y, so we want to get y by itself. So we need to multiply both sides by y. Okay, we get y times the tangent of 54 equals 13.7. Now we can divide both sides by the tangent of 54, which will leave y by itself. Okay, so we get y equals 13.7 divided by the tangent 50. Okay, which is, if we calculate it, 13.7 divided by the tangent of 54 gives us 9.95, which is going to be 10.0. So it's going to round up to 10.0. 9.95 rounds up to 10.0. So we know y here is 10.0. So we know y equals 10.0. Okay, we got to find z now. Okay, well, z is this piece right here. We know the whole base, right? We had to find the whole base because that's 32.2. Right? The reason we had to find the whole base is to find z. The whole base is 32.2. We know this blue piece right here is 10. So if we do 32.2 minus 10, that should give us this piece. So 32.2 minus 10.0 is going to be 22.2. So we know z is going to equal 22.2, right? This piece is 22.2. Add it to the 10, we get the whole thing, which is 32.2. So z is 22.2. Which is what we're trying to find. Okay. So we had to look at the big triangle first, find the height and the base of the big triangle. Finding the height of the big triangle allowed us to find y. That's the reason we found the height of the big triangle, is because that's the same height for the small triangle. Right? The height of the red triangle is the height of the blue triangle. So by finding the height of the red triangle, we knew the height of the blue triangle, and we could use that to do the tangent to find y, which is 10. Then we used the fact that we could find the base of the big triangle, the red triangle, and we could subtract away y to get z. We could do 32.2 minus 10 to get 22.2. Okay, 19 and 20. Here. Okay, so the input to a trig function is an angle. The output is the ratio. Okay, and then the inverse function is the opposite. It's the inverse. So you input the ratio and your output is the angle. So if we want to do tangent inverse, the input is the ratio. Well, tangent, right? So here's the angle, right? That's the input. And then the ratio, the value of the ratio is the output. So the input to the inverse function is the ratio. So there's 0.6249. Okay, and the output is the angle. So all we got to do for this one is put in inverse tangent, 0.6249. Okay, we get 32.0 degrees equals the angle. This angle right here is 32.2. The input to the tangent function is the angle. The output is the ratio of the opposite over the adjacent side. Okay, but the inverse function, we input the ratio, and the output is the angle that we're trying to find. It's the inverse, right? We just flip it. It's like when you find an inverse function, you flip the x and the y, then solve for the new y. All right, sine. So again, this is the input. It's the angle. That's the output. That's the ratio. So if we do inverse sine, we input the ratio, and we output the angle measured. So the inverse sine of 0.7547 is 50.0. I mean 49.0 equals x. 49.0 degrees. 21 and 22. Well, let's just start with 21. How long is this so far? 39 minutes? All right. We just got two more. Okay, in triangle MNO, the measure of angle N is 90 degrees. NO is 27, MN is 38. Triangle DEF is similar to triangle MNO, where vertices DE and F correspond to vertices MN and O respectively, and each side of the triangle DEF is 1/4 the length of the corresponding side of triangle MNO. What is the value of cosine D? So let's draw it, right? I mean, we're doing better at understanding how to draw it right away. So let's draw it. Let me get the black back though. Okay, so let's draw it. So this is MNO. It's telling us N is 90 degrees, so that's our right angle. NO is 27, and MN is 38. Triangle DEF is similar to triangle MNO, Okay, all the vertices correspond, and it's 1/4 the size, so it's a smaller one. Okay, D corresponds with M. It tells us N corresponds with E, and it tells us O corresponds with F. Okay, and each of those lengths are 1/4 the size. Okay, and there's really multiple ways we can do this. Okay. The easiest way we talked about was using the fact that corresponding angles are congruent. Okay, so we want to find the cosine of D, which means we want to find the ratio of DE to DF. Here's D, so adjacent is DF, hypotenuse is D. Adjacent is DE, hypotenuse is DF. So we want to find the ratio of DE to DF, adjacent over hypotenuse. Well, one way, again, the easiest way to do it is to find the measure of angle M. Okay. So let's find the measure of angle M. So if we want to find an angle measure, we're using inverse functions. Inverse functions. Okay. Hypotenuse is MO. 27 is across, so that's opposite. 38 is next to, so that's adjacent. So we have opposite and adjacent, that's tangent. We're finding an angle, so it's inverse. We're inputting the ratio and getting the angle. So inverse tangent of 27 over 38, opposite over adjacent, equals x. That's our angle measure. So we can put that in the calculator. Inverse tangent 27 divided by 38. That's going to be 35.4. 35.4 is x. So this angle is 35.4. Okay. What do we know about corresponding angles of similar triangles? We know the corresponding angles in similar triangles are congruent, meaning the angle measures are the same. So we know the measure of angle D is 35.4. So if we want to find the cosine of D, we can put in the angle. So cosine of 35.4. Okay, cosine of 35.4 is 0.815, so 0.8. Okay. The other way we can do it, okay, we can make x the hypotenuse here. Well, okay, we know, we can know. Well, let's do it on the other one. So we also know, we know the length of all of these sides are 1/4 the length of these. So we know 38 times 1/4 is going to give us 9.5. Okay, and then 27 divided by 4 is going to give us 6.75. So we could do the Pythagorean theorem, right, to find the hypotenuse here. So we could do 9.5 squared plus 6.75 squared equals x squared. So we could do 9.5 squared plus 6.75 squared. That's 135.18. Then we can take the square root of both sides. And we can get x equals 11.6. Okay, when you do that, that'll come out to 11.6. Okay, the ratio 9.5 divided by 11.6, right? Because 11.6. Right, so we have cosine of D is going to equal adjacent over hypotenuse. So here's adjacent, here's hypotenuse. So that's 9.5 divided by 11.6. Which equals 0.8. Well, I get 0.82, but that's a rounding issue. If we would have been more specific here, it's 11.6539. So if we do we do 9.5 divided by 11.6539, we get 0.81. Let's do inverse tangent 27 divided by 38. And then, yeah, so there's a rounding issue. So cosine 0.8, yeah. So it's about the same, 0.81, 0.8. Yeah, within both round to 0.8. Okay, 22, it's the last one here. So in triangle MNO, the measure of angle 90 is 90 degrees. Okay, and MO is 38. So M and O. NO is 27. MO is 38. Triangle XYZ. XYZ. I'll correspond. Yeah, so it's half the length. What is the value of sine Z? So we want to find sine Z. We know they're similar. Similar. Okay, so we know corresponding angles are congruent. So if we can find angle O, we can find angle Z. Okay, so this is adjacent. This is hypotenuse. We need to find the angle. We're going to do inverse. So inverse cosine of 27 over 38, which we just found. Inverse cosine 27 divided by 38. 38. It's 44. Oh no, sorry. What do we do? Last time it was tangent. Yeah. This time it's cosine. So that's going to be 44.7. Okay, so this angle here is 44.7. Okay. If we want to find Z, we know corresponding angles of similar triangles are congruent. So the angle measures are the same. So this is 44.7. So we can do sine of Z, sine of 44.7. That's going to be, let's do the sine of the answer. 0.70. 0.7. Again, we can do Pythagorean Theorem. So 27 squared plus, we can call it x squared equals 38 squared. So we would do 38 squared. We'd have to subtract 27 squared, then take the square root of both sides. Okay, we'd get 37.6. Okay. Sorry, what do we get? Let me try again. 38 squared minus 20. I missed the squared button. Then we take the square root of both sides, and we get 26.7. 26.7. So what's 26.7 divided by 38? It's going to be 0.7. Okay. Or we could, it's half. So this is 19. And this is going to be, if we divide that in half, we get what, 13.3? So 13.3 divided by 19. Right, so sine Z is going to equal 13.3 divided by 19, which equals 0.7, which is what we got doing it the other way. All right, and then 23, there's a video on the blog going over this post. Okay, there's a video on the blog here. 5 points extra credit on the test. You got to prove a squared plus b squared equals c squared using similar triangles. So if you can do that, 5 extra credit points on the test. Under 50 minutes.